Welcome to the 70th episode of Rising Tide, the Ocean Podcast. This is David Helvarg of Blue Frontier and my co-host Vicki Nichols-Goldstein of the Inland Ocean Coalition.
And hello, everyone.
And speaking of inland, today we get to talk with Dr. Carrie Wall at the University of Colorado, where for almost a decade, she's led the National Oceanographic and Atmospheric Administration's Fisheries Acoustic Archives. For those who remember the silent world of Jacques Cousteau, well, in fact, the ocean's anything but silent. Sound acts as the light of the sea, helping its creatures to feed, communicate, and mate. Much of Carrie's work has involved collecting and learning from the many sounds of fish in the ocean using sonar and passive acoustic listening systems. But before we get into all of that, Carrie, can you tell us how you first connected to the ocean in your own life?
Yes, I can. Thanks so much for having me here. I was always interested in the environments and in animals. And I think it was when I was studying abroad in Australia, when I was in college, and I had my certification in scuba diving. And so I would often go on the weekends to scuba dive in the Great Barrier Reef. And we did a spring break in Bali, Indonesia, and we're diving in the Indo-Pacific. A lot of these things were not related to classwork, I do admit, but it was really a wonderful time to immerse myself literally into the ocean and really start to understand the complexity and the animals and the fish that were there. And I just truly fell in love with it at that point. And from then on, my course was kind of set, and further graduate work was solely focused on marine science and oceanography.
And you describe your field as using sound to see critters in the ocean. Were you thinking about that when you were back a young gal in college and swimming around going under?
I don't think so, but one of the things that kept with me throughout graduate school was scuba diving, and just being there and you see all the fish. And so we are very visual creatures, and we use sound a bit as well, but because of the environment where we lived, our vision is kind of the most effective for long distance communication, or at least sensing of your environment. In the ocean, it's vastly different. We do get to wear these goggles, but turbidity and having cloudy water really affects how far we can see. And it's the same for organisms that live in those environments as well. And so they rely on their hearing a lot more. And when you are put in that type of environment, you do yourself start to need to use your ears a bit more to understand what's going on. You hear boats above you. You want to make sure you're not going up on a boat, or it's pretty intense when there's vessels around you. And if you slow your breathing when you're on scuba diving and you have your tank on and you're breathing, it's pretty noisy. And so you would often just want to stop breathing so you can hear what's going on. And if you do that, and you're especially on a coral reef, you can hear snapping shrimp. And it sounds like Rice Krispies in a bowl that you just added milk to. And that to me is just the most fascinating thing, is that, right, exactly just said, it's not a silent ocean at all. And it's just fascinating to be there in that kind of space to really experience it. And then I was certainly lucky enough to be able to take this type of passion, turn it into PhD research where I studied fish sound production, and then into the position that I have now that continues on and understanding sounds of our ocean.
And they're amazing. I mean, I've done the same diving. You stop breathing and you listen, and especially around big parrotfish, you hear them crunching on the coral, and they eat the algae and coral and poot sand, and that's where our white sand beaches come from. You hear the sounds of whales occasionally, or the clicking of dolphins. And I mean, there's really so much sound in the ocean. I guess that's what you do, is you try and categorize and collect them.
Yeah, that's exactly it. And, there's a lot of people who specialize in one critter or the other. I went into fish, and not many people know that fish make sound, but they do. And there's a number of species that do make sound, vastly different sounds than you would expect from the well-known humpback whales or dolphin whistles and clicks. And then, of course, you have the people who study this fantastic charismatic megafauna, or whales and dolphins. And so you kind of really start to understand a specific component of sound contributions to that ocean. Or it might be that you're interested in understanding the impacts of anthropogenic noise on from vessels or from seismic activity. And then, once you start to learn about one of those specific parts, it's usually one of them that calls you into understanding that research and getting into it. But it's all connected and they're all overlapping. And so it's really fascinating to start to see these pieces come together. It is like a symphony. You have I just went in there to study fish and I just wanted to look at red grouper and quickly realized there was far more than red grouper producing sound, including species that we had no idea what species was making that sound, but it was a really interesting sound that we documented.
So you're right. People really don't think about fish making noise to communicate. So when they're making this noise, what are they communicating and who are they communicating with and to?
Oh, and what are they sounding like?
I'll do a couple of fish sounds for you, and then I'll answer Vicki's question. So there's a couple of my favorite species. There's two of them. There's red grouper, and then there's toadfish. A couple subspecies of toadfish, but they all sound kind of the same. So red grouper, they make low frequency sounds, this low pitch, because of the way that they make their sounds. It's used through the use of a swim bladder. It's this air bubble in their body, and they contract muscles around it. And basically, they create their own personal drum. And there's other species that use bones. They kind of click bones together, sort of a clicking sound. But the tonal sounds come from these sonic muscles being stretched across the swim bladder. And so red grouper sounds like this. Pretty interesting, right?
And like they ate too much.
Yeah. And then there's the boat whistle call for a toadfish, which really kind of sounds like a boat whistle. It goes, maybe my frequencies aren't quite right. I'm a little bit rusty.
Here in the Bay Area, for years, people were thinking there was like underground electrical cables humming. And what was that sort of had that electric hum constant sound?
There are so many fantastic stories about earth-shattering things happening in our bays, and it turns out it's just fish making sounds. So there's a species called black drum, and the sound that these black drum are making was so loud in the canals of Florida, and the sound was emanating up from the toilets in these houses. That people are complaining about sounds that they were coming up from the toilets in their houses. What could possibly be making this sound? And it turns out it was in fact black drum and red drum, just really, really low frequency sounds they make all the time. There's also midshipmen as a type of fish, and they're well known, going back to Aristotle times. They just produce sound and it just goes all night long. And if you're on a metal fishing boat, as they were back in the day, it just resonates off of this metal fishing boat. And it's just this cacophony of sound, and it just won't stop all night long. And so there's some very characteristic things that fish do when they make sounds. And one of them is largely they produce them at night, and they can do it for a long period of time. It's called chorusing, and they all kind of get together. So to answer Vicki's question that she asked, who's making the sound and why? A lot of it has to do with interaction with their own species. So let's say it could be a male, and he's territorial, and he sees another male coming into his area, and he says, "Hey, this is mine, get away." And so he'll produce sound to create agnostic behavior against another male. It could be courtship season, and so they're trying to find a mate, and so they're trying to attract a mate by creating sound and getting the females to come mate with them. So those are kind of the two main reasons. The real drivers of any species in the world is protecting your territory and finding a mate.
So yeah, we associate sound with marine mammals, but it sounds like there's a cacophony of fish noise out there.
There absolutely is. And we're still learning a lot about it and what species are creating those sounds and for what reasons. They're a little bit harder to study when they're down on the seafloor and they don't come up the surface for air.
And what's the goal of studying fish sounds? Why do we have a big library of animal sounds? What does that do for us, humanity, for our civilization to understand this?
Yeah, there's a couple of really important reasons why studying fish sounds is important. As I mentioned, some fish produce sounds for courtship, which is highly related to their spawning time periods. And if we're going to effectively protect a species and they produce sounds during courtship, you want to know when that exact timing is for the spawning so that you can mitigate impacts from fishing during that time period. The grouper, red grouper is one of them, but there's many other species within this grouper family. It's called a grouper because they all get together during spawning, and there's tens to hundreds of them coming into this one area. Real prime fishing time, but not when you want to
preserve a species.
Yes, exactly. They're highly susceptible at this time, and you want to really effectively manage them. And if you can do that through sound, it is a really nice immediate feedback. Say, oh, the sound production is increasing at this time. We know that the moon cycle is this. We know the time of year and the temperature is that. So we're going to kind of adaptive mitigation to protect this species in a really effective manner. So that's one way. The other, an example is Atlantic cod and the use of bycatch. And so fishing boats are out there. They can only collect so much bycatch, so much species that they are not targeting. And you really don't want to collect Atlantic cod when you don't have to. It really affects your ability to go out and be an effective fisherman, as well as, follow the guidelines to protect the species. So if they're producing sound and you can hear that and you have a recording device and it's picking that up, it allows you to adaptively manage your fishing opportunities to avoid the species because they're producing sound. It's also a non-invasive way to understand a species. As I mentioned, they don't come to the surface to breathe the air. How do you know that they're down there? Well, single line sampling used to be a really important way to do it. But now you've got a fish out of the water and they don't really survive very well like that. So it's not really helpful to understand what species are down there if you're constantly taking them out of the water to find that out. So you can put down non-invasive monitoring efforts that are provide information during the night when we can't use scuba divers, for example, or video, or it's in very rough waters or rough weather. Again, when boats can't go, when videos aren't effective, and when divers, it's just unsafe.
So this is hydrophones, and it's also like ASOC. During the Cold War, the Navy had massive arrays of listening devices listening for Russian submarines. And when the Cold War ended, I guess that became a huge resource for scientists to listen into more sounds of the sea.
Yeah, that's exactly right. And so, yeah, hydrophones are just underwater microphones, and it's attached to this instrumentation connected to the hydrophone. There's a microcontroller there. It's a very small computer that tells the hydrophone when to record, where to store the recordings, stores those recordings, and there's batteries there to keep everything running. And of course, a container that can handle the cold pressure and wetness of the ocean. And our technologies and our ability to expand our monitoring using passive acoustics is incrementally bumped up through every war or Cold War effort, because the technology that gets trickled down does come from the Navy.
And the creation of sonar initially in World War II, they had the deep scattering layer. They had no idea what all this noise was, and it was your snapping shrimp.
Yeah, it was been part of the snapping shrimp. So they called it the phantom bottom, the phantom seafloor. It's just this really fascinating story of really not understanding our environment, but yet using technology to get us there. It was kind of a cart before the horse type of a thing. It really helped us to accelerate our understanding of the deep scattering layer, which is a layer in the water column that rises at night and sinks during the day. Yep, sorry, got that right. And it's about 200 to 400 meters deep, and they're little lantern fish. They comprise the largest part of the deep scattering layer, but really, really valuable, important part of our ecosystem. And it wasn't discovered until we had till World War II, when they started using sonar, and it was quite the conundrum for a while. They thought that seafloor was changing. Clearly not. It didn't take them long to figure out that wasn't true, but it was very unexpected.
So how many different species are being monitored now in the ocean? And I'm sure it's coming from a variety of areas. So give us a little bit more information about that topic.
Yeah, how big's your collection?
Those are a lot of different questions, and they have a lot of different answers. The big picture here is that with the introduction of batteries that can last longer, memory storage and batteries that are smaller, and memory storage that is bigger and bigger in volume, but smaller in size, it allows us to put more and more acoustic recording equipment out into the ocean for longer. You can integrate it into various platforms like a glider, an underwater autonomous vehicle. And so we have more ways to collect passive acoustic data, or even active acoustic data. And so our ability to collect data is really not a limiting factor anymore. It used to be you just kind of were on the side of a dock, and you had your hydrophone, and it was a whole connected system. You couldn't put the whole thing underwater, and you had a computer that you just actively listened to the sound. We are far more advanced, and so there's recordings that go way down deep into the ocean. And either it gets acoustic release and it comes and pops up to the surface, or you have a fleet of autonomous vehicles that go out and they collect data for you. Or you can even attach these types of sensors to animals themselves, for example, whales, and collect all sorts of additional information on top of that. So we were able to collect so much data. We have almost 300 terabytes of data in our passive acoustic archive that we have at NCEI, nearly 200 terabytes of water column sonar data and our active acoustic side. So much data are being collected. And the question of what are we doing? What are we understanding? What are we learning about? What species? It's becoming more and more feasible to answer questions we never thought possible with all of these data. So it's largely anything that produced sound at that time that you were recording. It kind of becomes a little bit unknown of what can we do with all of this data. What are the limitations? What kind of things were interfering? You can also understand boats now or hear sounds that we never knew were being produced down under the ocean.
You also have a tremendous amount of external noise sources that are going into the ocean, from military sonar, vessel traffic, exploration of both fossil fuels and now new alternative forms of energy, like in the case of offshore wind development. How do you sort through the different types of sounds? So you're understanding the natural sounds, the artificial or human-made sounds, and then also, third question, sorry about this, how they may interplay with each other.
Yeah, these are really great questions. Biological sounds are very pretty well known. I mean, we don't know everything, but we know generally what a humpback whale is going to sound like. They have a very complex repertoire of sounds that they make, but they're all pretty humpbacky, right? And then we have North Atlantic right whale. We have a lot of very well documented species that are out there. And then you have vessels, and that is a vastly different sound. It's very mechanical, it's very broadband. It gets real loud once the source is really close to the hydrophone and then goes away as a Doppler effect. You listening to it, you're like, yep, something just went past the hydrophone at a speed that a whale is not going to produce. Pile driving from the development of offshore wind energy is a very specific sound. And so we can develop detection algorithms, and other complicated ways to process data to extract out these specific sound sources so that you can understand, okay, here's when all of the pile driving occurred. Here's when vessels were present in the area. And vessels can be pretty tricky. Pile driving is really, really loud, but it's pretty instantaneous. Vessels can stay in the area. They can have seasonal effects on just the general ocean noise levels. It just gets louder because of all of the vessels and sound being transmitted across a lot of distances. And it can overlap other sounds being produced by biological species. So you're like, maybe that was a humpback whale in there, but I can't quite tell because all you really hear is the humpback. All you really hear is the vessel instead of the humpback. So it gets a little complicated to say that was a vessel, that was a humpback whale for sure. When they're separated, put things on top of each other. That's again when we have this nice cacophony of what's going on in our ocean and how it's changing based on the contribution of sounds and increasing components of those coming from humans.
Are fish sounding difference in the presence of anthropogenic sound, or is that a study even being conducted based on the data you've collected?
That's really interesting. I don't know that specifically. Effects of the, changes in the vocalization of fish based on vessels. I don't know. And so that has been documented with whales. They've seen them kind of change their pitch. The way that whales produce sound is far more complex compared to fish. Fish are pretty rudimentary, which means they have not a lot of ability to change their frequency and change the way that they produce sound, especially as far as pitch. So they're very muscular. A lot of them are doing it based off of muscles. And so it's muscle contraction rate that will dictate what frequency of sound they're able to produce. I have found in other states as well, and that some species that change in temperature causes them, if the temperature decreases, it causes them to produce sound at a lower frequency because their muscles are contracting slower. And so that's not like a neurological change for them. They're not thinking, I need to figure out how to avoid this vessel noise by making this adaptation. It's really just a physiological thing. So that is really interesting, but maybe timing of when they produce their sounds. I'm not quite sure. I'd have to look into that.
Oh, a quick, totally unrelated follow-up. When I'm diving, there's usually in the reefs, there's usually a lot of grunts. Is that fish named after its sound?
Yep, we're not very original when it comes to naming fish. We have drums and we have grunts, and it's because they sound like a grunt. Yes, that's exactly it.
Could you give us a grunt fish sound?
I don't think I'm going to do it justice. It's looking like a kind of a sound. I'm a little bit rusty on my grunts.
Okay.
So, I could mention earlier, we have a lot of activities in the ocean. Are there sections of the ocean that are quiet, or has sound penetrated the entire water body?
We try very hard. We, as in the federal government and NOAA, especially the Office of National Marine Sanctuaries, tries very hard to find those critical habitats to protect. And that's when national marine sanctuaries are created. For a variety of reasons, but mostly it's to protect the species and protect the environment that's there. The Papahanaumokuakea Marine National Monument off of Hawaii is probably one of a few remaining fairly, not completely, fairly pristine marine environments. There was a recent monitoring effort that went over 3 years. It's called the NOAA Navy Sanctuary Soundscape Monitoring Project. And that recorded sound for 3 years at 7 national marine sanctuaries and 1 marine national monument, the Papa one being the Marine National Monument. And the analysts looked for vessel sounds at all of these across the 3 year sound period. And they found vessel presence, the noise from vessels, in all 7 of the national marine sanctuaries that they recorded sound of. But the National Marine Monument never really recorded vessel sounds. It was a lot of influence from humpback whales. It's prime humpback whale area out there, but it was just minimal to zero vessel noise out there. So I find that that's great. It is nice to know that we do have parts of our sea that have not been completely dominated by vessel presence, and I do hope that it stays like that. So that's one of the potential ones that remains within the U.S. zone.
And that Papahanaumokuakea monument is huge, and it contains 70% of U.S. coral reefs, for example, and lots of endangered or rare species from monk seals to tiger sharks. Sharks make noise?
They do not, unless they're just swimming past you.
Sanctuaries. I think people who listen to our show know how much we love marine protected areas and support them, and national marine sanctuaries. And I used to work for NOAA in the sanctuaries department. I didn't realize that they were using sound as a potential for the designation of new sanctuaries. And I think that's such a fascinating idea, because I know we look at the benthing environment, the natural history, but that's such an interesting concept to think about the soundscape as part of. If you have an area that's quiet, how do you keep it quiet? How do you maintain that natural element to it? So that I'm just inspired to hear that. I think is really cool to be thinking on that level.
Yeah, and I think it's twofold. One of it is can we keep it quiet, and how do we do that? And which is incredibly vital. But the other part is, okay, we can't keep it 100% quiet. Vessel traffic is going to happen. How do we mitigate? Are there things that we could do to lessen the noise? And does that have to do with reduction of vessel speeds, which will make them quieter? Or how do we protect the species that we know are going to be in that sanctuary at these times of year? There's a lot of whale species that are highly migratory and reside in sanctuaries during key periods of certain seasons. And so through all of NOAA, there's an ocean noise strategy roadmap that outlines the goals of NOAA's ocean noise strategy, which is and to offer approaches to a more integrated and comprehensive understanding and management of ocean noise and its impacts on protected species and acoustic habitats. And so it's a big component of national marine sanctuaries, and it is echoed throughout many monitoring efforts across NOAA.
And before we go, is there anything that you want to share? Because I think this is a new and emerging field, and I'm sure a lot of young people might be thinking, wow, what a cool opportunity. Can you share a few things about how you might get into this area?
Sure. It is a very cool and exciting field. I love it with all my heart. And with anybody who knows me knows I can talk a lot about acoustics. And so they often don't ask me because I kind of continue to go on and on, because there's so many interesting aspects of acoustics. And you don't have to love fish, or you don't have to love whales, or you don't have to love dolphins, or you don't have to love vessels, or you can love all of them, any part of it, right? And it has so many impacts on our oceans, from tourism to the seafood industry, to climate change, and so many more. And so I would say get involved with whatever you can that has to do with marine science, and be open to any opportunity that becomes available to you. I did a lot of free internships when I was going through college. I don't recommend the free part of the internship, but these are really fantastic ways to get more and more experience in the marine science realm. So take any opportunity you can to get involved in any sort of research that comes your way, and be open to new opportunities like that. And then just start learning about sound.
And do you have any other favorite fish sounds you'd like to share before we wrap up?
I think you got them all. There is, I'll share one of the species that we recorded in the Gulf of Mexico. And I still, to this day, I'm not sure what kind of species it was. We never were able to 100% pin it down. But it sounds like this. And so it's the sound that has this frequency modulation. And it's very unusual to have a fish do that. And when you get, I don't know how many, because they're underwater and I can't see them, let's say 10 of them together, and they make this sound at night, all night long, it kind of sounds like cows mooing in a field. Or, it's like this tuba sound, or it's also been kind of called like a jet ski sound. And it's just fascinating that there's something down there under the water producing this mooing jet ski tuba sound for hours on end in the ocean, and we never knew that was going on.
Well, we might have to dig into your library to enhance our show so we can share some of these sounds. I just am fascinated with this, and I'm sure David is too. And we just want to thank you so much for taking the time to share your experience and a little bit more info about underwater sound. And thank you so much for being part of the Rising Tide Ocean Podcast.
Thank you, David. Thank you, Vicki. I appreciate the opportunity. It's been a pleasure.
Rising Tide is a production of Blue Frontier, co-hosted by David Helvarg and myself, Vicki Nichols-Goldstein, with support from Natasha Benjamin and Ellie Kurla. Rising Tide's editing services and technical support is provided by Studio Cape May. The theme song is written and performed by Ethan Kenbarg. You can find Rising Tide, the Ocean Podcast, at bluefront.org, or download it from Apple, Google, Spotify, or wherever you get your favorite podcasts.
Off in the salty ocean, off where the waves roll free, the sparkling water rises, then crashes to the sea. Out amongst the breakers, you'll have no need to fear. It's true, it's the Blue Frontier. Off in the salty ocean, off to the Blue Frontier.
Sparky, come here, buddy. Sparky! There you are. Good boy, Sparky.